So welcome folks, welcome to SingDev Insights, and you're watching my daily Leetcode challenging series. And in today's video, we'll be covering problem for the 4th of March daily Leetcode challenge. So before wasting any time, let's dive into the problem. So today we'll be covering problem for 4th of March, and it is going to be an exciting problem. I just read a bit of it before starting, so before wasting time, let's dive into it and see what instruments of DSA we will be using in this video. So let's go through it. So the problem code for the Leetcode is 948 and the problem name is pack of tokens, and it is classified as a medium problem. Okay, let's see like if it is a medium one or what. So as you might have seen in my previous video, the strategy that we use to solve a problem is, first of all, we actually read the problem, we go through the examples and see the constraints, and then think of the approaches. So the idea is first to understand the question, not directly just jump onto the coding. So to actually solve any problems, you don't need to think in code. You just first need to understand the problem. What is the problem saying, and what do you want to achieve through it? So the the thing that you shouldn't be doing in any coding interview or wherever, even you are at work, never jump onto the coding part first. First think of the approach and just think how the solution will work, and when it works, then make it clean. So there are different stages while solving a problem that I'll be showing in this video. And in that is my goal, that we just don't want to solve the problem. We actually want to understand the way how to reach the problem solution, and also when you are in an interview, how you should be saying the problem and what should you be doing. Okay, so let's go to the problem. So as the problem name says, back of tokens, let's read the problem statement. You start with an initial power, an initial score of 0, and a bag of tokens given as an integer array tokens, where each token I donates the value of the token. Your goal is to maximize the total score by strategically playing these tokens. In one move, you can play an unplayed tokens in one of the two ways, but not both for the same token. And I think they are telling what are the two things that can be done with the token. One is said to be face up. If your current power is at least tokens I, you play the token. Losing tokens, that particular token that we lose that amount of power, tokens I power, and will gain one score. And when there is another move, like in the same move, the other thing that we could be done is face down. If your current score is at least 1, you may play token I, gaining tokens I power and losing one score. And okay, and then we want to return the maximum possible score you can achieve after playing any number of tokens. So okay, so just let's first write on what we have been given. There is the initial score given as 0, and we are given tokens I, where there will be elements like tokens I, and initial power is also given. That is already defined. We have these inputs already told. We want to maximize the possible score that we can achieve after playing a number of tokens. So as I see, the question nowhere asks that we should be using all of the tokens. Like for example, like let's first see how what is the input kind of given in the example. So we are given a token array and a power. Okay, these will be the inputs for the question. Okay. So for example, in this case, power 50. Yeah, just before going on to like what are the things that we can do, like if current power is greater than or equals to tokens I, what can be done is we want to current from the, this is one of the operation that question says, and don't forgetting the current score to be incremented by 1. Okay, this is one thing that we can do. Or we can take the current, if your current score is at least, so at least means greater than or equals to, then current power will be increased by, we don't know what token amount will be increasing, but it says if we are playing for that move some ith index token, we'll increase the power by that and then decrease the score by 1. Okay, these are the two things that can be done. Okay, now we know what we can do. Yeah, I just kind of extract the information that is given in the question, because if you go to some coding website like Code Forces or CodeChef, there is always a big problem statement that is given, and you don't want to spend time just reading the whole problem again and again just to figure out the key information from the question. So read it once, twice, and extract the key information from the question and place it somewhere so that you know what is given in the problem, and you can just think of the problem and removing any extra part that is unnecessary with respect to the problem. So, and always remember what we want to achieve to maximize. I think this statement whole works right here. Now we know what we want to do and what are the given inputs. Now let's actually see the examples. We are given an example in which tokens array is 100 and power is also 50. Okay, so in this case, initial score is all like, since the initial score is 0, there is obvious one thing that we cannot perform this operation, and the other operation in this case cannot be also, because power 50 is less than 100. So it is, so yes, score will be, maximum score will be 0. Yeah, but in this case there was only one index. What happens, how to think when there are more index? We just want to develop that thing, like how it should be done. Okay, in this case we have initial score 0, so one operation that can be performed is 150 is less than 200, but 150 is greater than 100. So that means we can subtract the power in one operation. First operation, we can just subtract it and it will be 50 for the power. In left side I'm writing the power, and right I'll be writing the score. So initial score was 150 and then it was 0. Now we come to the second operation, and one thing that I think question already mentioned, one token that is already played that cannot be played again. So right now the power is 50. So if I see current score is greater than or equals to 50, and one thing to make sure, after playing any number of tokens, so right now suppose we want to end, we don't want to play the another token, assuming okay we don't want to play more. So till now the maximum score that we achieved, I guess, is 1. Now we keep it stored somewhere. Okay, we have a maximum score that is can be achieved. Now let's go on with another operation. Current, in the next one, current power is greater than or equals to token. So 100 is already utilized and 50 is not greater than or equals to 200. So this operation can't be performed, but current score is greater than or equals to 1. So we can increase the power by 200. So that one is also utilized. So it will become 250, but score will become 0 because we followed the second condition. So at any state of moment, if we see the score after the second operation and the first operation still remains to be the 1. And yeah, this was the only choice. So I think that way, yeah, output should be 1. I think we understood the question correctly, that it doesn't matter that you need to cover all of the tokens. You can just actually go till a particular state, and if you want to play, you can play. But if you don't want, then just avoid it. And just at any state, you need to keep a maximum score. Okay, from this example, we got more clarity. Now moving on to the other question. No, sorry, the other example. We have this token array given, and power is given as 200. So as the question says, the idea is to maximize the score. So if you want to maximize the score, so we don't want this score to be reaching to 0, but we just want to reach, we are fine to go with this condition, because whenever we are going with the second condition, like if the current score is greater than or equals to 1, then yeah, obviously we are increasing power, but we are decreasing the score. But question wants that we want to maximize the possible score, and in order to maximize, that means we have to follow the first principle to increase it, but making sure that that operation is performed like optimistically. Like you don't want current power, you don't want an index for the tokens that is kind of closer to current power, so that when you subtract it, you'll get a lower current power. So let me tell you what I mean. what I'm sensing right now from the question is, for example, right now our power is 200. And always in this question, I think one thing to keep in mind is we want to maximize the score. So focus should be on score, that current score should go maximum. And so if we think of the operation 1, and the current power right now initially is 200 and there is no current score, so we can do either pick up the index number 1 or 0. If we pick up the 0, then our current power becomes 0, that is, yeah, 0. But if we pick up 100, we still get some value, and that can be used in later operations. Okay, I think that makes up clear more things, that whenever we want to pick token index for first operation, we want to pick small value. I think that much is clear. Now thinking on the other note, for the suppose if our current score is greater than or equals to 1, we want to increase the power by the tokens with that amount of index. We want to, and current power actually makes sure, if the current power is greater than some particular index token, it makes sure that we, when it's decremented, there is also one thing that's going to happen, score is going to maximize. So there is kind of an interdependency that we see. So whenever we want to increase the current power, we want to make sure to pick a particular token index that is maximum, that has been unplayed till now. So I think the another thing that I could find is, when we want to pick the token index for second operation, we want to pick large value. Okay, my screen seems to be like, okay, so we have a clarity. Whenever we want to pick the token index for the first operation, we want to pick the smallest, and we want to pick, whenever we want to pick the token index for second operation, we want to pick the largest. Okay, I think this information is very informative. Like, I think this makes problem more easy, like the condition is improved. And so, but in this, one thing that I see is, let's first check the constraint. Also, constraint seems to be low and power seems to be like this. To be honest, one thing I have developed by solving so many lead code questions is, whenever I see the length like this, an optimization problem, and I could see there is a thing that is happening whenever I'm reading question, is like, it gives me, okay, whenever I see these kind of conditions, okay, we want to perform this operation or this operation, or we can leave something, then it gives me, because of a lot of practice, it gives me intuition like, okay, there is somewhere gonna be dynamic programming. And I know this problem without even reading, okay, if it could be done with dynamic programming. But I think I know in some of the discussion solution there will be dynamic programming. But right now, the way I'm thinking it can be also done without dynamic programming, and this is what I'm thinking. And I don't want to bias this video with dynamic programming, so I'll continue on what I'm developing right now. So we have two conditions. Okay, we have two things. Whenever we want to pick the token index for first operation, we want to pick the smaller one. So at a particular state, we want to make sure that we have a maximum score saved somewhere. And I think this information is enough. And given the constraint, one thing we can do is, first of all, let's make it clear. I think we have found the core part of the problem, that when we want to pick the token for the first operation, then it should be pick the smaller value, because that would make sure our current power is not decreasing by that much value if we pick the smaller. And for the second, make sure that current power is of higher value, so that in the next operation, the token that is used of the lower value would make sure that like that we are increasing the current score. Okay, and the one thing that I'm right now thinking is, since I'm seeing a kind of thing that I want to pick the smaller and a larger, what would be the efficient way that in which I can, whenever, if I'm iterating over the this array, to pick a smaller value whenever I want the next smaller value and the next larger value if the largest value is used. I think one thing that I could do that could be useful here would be sort the array. Okay, so right now till this point we have developed the intuition that we want, what we want to do. Now let's think of the coding part. that how should we doing it. So for this problem, I'll be coding in Java, and usually I prefer the Java language because I use it mostly in my work. So let's dive into the problem. It's already set to Java. First, whenever we are working through a problem, we actually make sure that we take the length of the token array, and always make sure that the variables that you are using are making sense, because when in the end the interview is not just about solving a problem, but the recruiters or the interviewer wants to know, like, if you are in a company, if you could write the production code. So if your optimized code is matching with some other person and your optimization levels are matching, then this would be the thing that they would be thinking, the readability of the code. So make sure on that part. Okay, so right now length of the token array is this, and at a moment what we want to track on is current score. So let's do some initializations that are coming to my mind right now. We always want to make sure we have this current power somewhere, current score somewhere, and at a particular point we want to know what is the maximum score also, and in the end we want to return that only. So this is a kind of a structure that I'm expecting. And now what I want, in order to do this operation efficiently, what we can do is we can actually sort the array. So we have smaller elements in the left and larger elements in the right in the ascending order. So we just want to sort the array. Now if we want to pick the lower element, we should be having iterator to it. So lower pick index, let's name it like this, and higher pick index, that is should be len of token array -1. Yeah, I think that's what we have. Now comes the part where it's just a preference that I write every variable in the separate line, and it's with the practice that I have developed while working in the company, but I think it depends on you or how you prefer, so don't get biased on this. Now I pick the smaller element in one operation, I pick the larger element. I'll move like this. If I picked one, I will move to the next smaller if the smallest is picked up, and if going with the other kind of operation, then it would the array would be like moving the left to the right and right to the left, and with this somehow we will be meeting at a point. So that can be a closing situation, like the base condition that we can have for the loop. So maybe what we can do here is making sure, wow, amazing. So to be honest, I prefer like this, and don't ask me why it is just what suits to my eye while I'm coding. Yeah, these are some biases that we develop with time and preferences. Higher pick index, lower pick index. Now there are two operations that we can do. And now the thing comes is we are having two condition, which one to keep first. Either I could just write current score is greater than or equals to 1, then do this, and if not, do this. And sorry, here it would be if current power is greater than or equals to uh, tokens of for the power we want a lower value. Okay, so it would be lower pick. So now the question comes, which one to keep first.